Every star we see in the heavens has a giant nuclear reaction raging at its core. It's what makes a star like our own sun shine so hot and bright. Only the nuclear reaction holds gravity at bay. The energy pushing outwards, stopping the sun from being pulled tighter, smaller, and more dense. It's a precarious balance that gravity will always win in the end. When the sun runs out of nuclear fuel, its own gravity will crush it into a tiny ball the size of the Earth, but 100,000 times more dense. But our sun has too little mass and therefore too little gravity to become a black hole. Instead, astronomers call such a feeble ember a white dwarf. But when a giant star switches off, it goes with a bang. While we see the outward explosion as a supernova, this masks the implosion going on inside. The core has been given a gravity bear hug, so extreme that all the atoms have been squeezed into a ball of superdense subatomic particles called neutrons. It has become a neutron star, a mere 15 miles or so in diameter.
We know that ordinary stars like the Sun will become white dwarfs. We know that there are neutron stars, which are just a little bit heavier. And the question is, do you have beyond that? And we believe it's black holes.
Theory suggests that when a neutron star is more than 3 times as heavy as our Sun, even the neutrons cannot resist gravity. The collapse is irrevocable. The density of mass becomes so great in the center that gravity overwhelms space itself, distorting it so horribly that it, and time with it, begins to wrench off from the outside universe. A darkness forms at the heart of the collapsing star and moves relentlessly outwards as the star's brilliance is sucked in. As the star dies, a black hole is born. Just how a black hole can manifest itself so powerfully in the emptiness of space is something that weighs heavily on Professor Stephen Hawking. Born exactly 300 years after Isaac Newton, Hawking now holds Newton's old job at Cambridge University. His body may be trapped by a crippling disease, but Hawking's mind is free to roam in the universe of Albert Einstein.
We are used to thinking of gravity as a force that pulls bodies towards the Earth and pulls the Earth towards the Sun. But Einstein had the brilliant idea that gravity could be caused by space and time being curved rather than flat.
Einstein realized that nothing can exist at a point in space without existing at a particular time as well. Space and time seem to be woven together to form the flexible four-dimensional fabric of the universe, so-called space-time. Space-time is almost impossible to contemplate because our entire sensory existence is limited to the 3 dimensions of everyday experience.
Holy macaroni!
The easiest way for us to enter Einstein's universe is to imagine space and time to be like a sheet of rubber.
If space-time were empty, the sheet would be flat. But massive bodies like the Earth and Sun will bend the sheet and cause it to be curved.
This curvature is Einstein's concept of gravity. The more mass a star or planet has, the more steeply it bends space-time around it, and so the more gravity it has. Throw something extremely heavy like a collapsing star onto the sheet, and you soon end up with a universe full of holes.
Ow! Watch it, Coney! Yeah! Oops.
As the massive star cools and shrinks, it will curve the spacetime around it more and more. Eventually, when it shrinks to a certain critical size, it will quite literally create a black hole in spacetime. Things can fall into a black hole, but nothing can get out.
Oh, there's so much I don't know about astrophysics. I wish I read that book by that wheelchair guy.
The most terrifying concept in astrophysics lurks at the bottom of a black hole: the singularity. Everything that has ever fallen into the hole is destroyed at the singularity, crushed into a pinpoint of infinite density and infinite smallness. Even space and time are squelched out of existence. All that remains in the outside universe is a perfect sphere of absolute darkness, a gravitational ghost of the star that died. This sphere is called the event horizon, and it marks the edge of the abyss.
This event horizon is not made of matter. It's, in some sense, almost not even made of a warpage of space-time. It's just a location. It is that unique location where gravity becomes so strong, just inside there, that nothing can escape.
While the event horizon may be only a few miles in diameter, the immense gravity of the singularity will have sucked a hole inside it that is impossibly deep to measure.
In the center, there is the so-called singularity, which is a place where, according to Einstein's theory, everything goes infinite, where if you do calculations, as it were, the smoke pours out of the computer and something goes wrong. And what that means is that deep inside black holes, we have a signal that we need some fundamentally new physics to understand what is going on.